Thanks, folks. Thanks for coming to my talk, and thanks for the warm welcome. It's been my first time here at Jay on the Beach, and also first time in Malaga as well. So it's been wonderful so far. So yeah, let's get into the talk, right? So it's about logs. I like logs. That's why I'm here. I believe everyone here at some point in time worked with logs in one way or another. And logs comes from everywhere, right? So it can be from your own application, or your dependencies, or from your infrastructure. So either you are an on-prem user or cloud user, doesn't matter. So your infra also emits large volume of logs, right? So in fact, the very first program, I assume everyone here would have written, like hello world, is nothing but a piece of log line putting somewhere, hello world, right? So yeah, but what can you do with all these logs? Can you make it useful? Can we extract something useful out of it? But how? I'm Kavi. I'm an engineer at Grafana Labs. I'm also one of the maintainer of Grafana Loki open source project. And yeah, this talk is all about Grafana Loki, a modern logs database that I'm trying to convince you to use it. So we'll see how it goes. So before getting started, just a quick poll. May I know how many of you here already know or heard about Grafana Loki before? Can you raise your hands, please? Oh, okay. That's a good number. Can you keep your hands up if you're using Loki or in your personal project or in your company? Okay. I see one hands up. Cool. So the agenda is simple today. So what we're going to do is we're going to first understand, get a bit of taste of Loki, how it feels like using Loki both as an end user who is querying for logs and also like an operator who is running Loki at scale. And then we'll take a quick sneak peek in behind the hood, like how some of the internals of Loki, how some of the core abstraction being designed, some trade-off there. And finally, we'll wrap it up with, I'll show you some patterns that we learned over a period of time by running Loki, by using Loki, and how can you take into your own practices. That's the goal today. All right, so why do we even need a new logs database, right? Probably everyone here already been using something, right? So why do we even care? Why do we even need a new database? So the goal is to have some simple tool that works at scale, right? So as a developer, so what I mean by that is two things. One, as a developer, we are familiar with these Unix-based tools, you start with some basic search, then you pipe with multiple filters as you go. That's kind of like a Unix philosophy we are all familiar with. So can we take that similar experience and put it at scale, right? That's a one point of view. The other thing is, how do we operate some huge database, like logs database in this case, at scale? What I mean by that is easy to configure, less tweaks, less optimization to do, those kind of things. So that's the goal. That's why the Loki is born. So what is Grafana Loki? It's the picture below should give you a bit of an idea. So think of it like a normal database where you ingest your logs and you query it back, and so it's a distributed system. So it have all the scalable component to it. So the thing to note here is it's also multi-tenant. So what that means is you have a single instance of Loki can be served for multiple users. So we provide the isolation both from the storage layer up to the query level. So each tenant is isolated, basically. That's what we mean by multi-tenant. And it's built for operators and developers, which is exactly what I said last. The goal is basically having some simple tools which developers are familiar with and make it work at scale. And also easy to operate, less configs, less optimization to do, much simpler configs, basically. So that's the idea. It's a relatively new project, launched in 2019 as open source. And the important thing to note here also is one of its required dependency is just object store. So all your persistent data is stored in object store. So that's also one of the design went to it for the ease of operation, right? So it's always easy to manage a single dependency with object store rather than dealing with a disk and other things. Of course, you can build a different kind of cache on top of it, but the object store is only dependencies for Loki. What Loki is not, It's not like a full text search engine. So hold on to the thought. We'll come back to that, what I mean by that when we see how it works. And it's not a store for metrics, traces, or profiling. So there is a small note there. So using Grafana Loki, like there is a language called LogQL designed for log processing. You can generate the metrics on the fly, but we don't store it, the metrics itself. So, and it's definitely nothing to do with any AI, and it's definitely not a chat GPT. So yeah, let's get started with the first thing, right? So first things first, before even querying your logs, you need to ingest it somehow, right? So Loki, if you're already using some kind of agent to scrape your logs, like FluentD, FluentBit, that is high. So Loki already supports in all the popular agents already. So that is one also comes out of the box. With Loki, it's PromQL, and that is another thing called Grafana Agent, which is if you're using Grafana Cloud, the agent can scrape all your metrics, traces, and logs. So it also has a first-class support for Loki. So the interesting thing to note here is Loki doesn't do anything special processing during ingestion. So why it matters? Because then we don't care about what format of logs you are sending, right? It can be from your bare metal, it can be from your VM, it can be from systemd, it can be JSON, log form, doesn't matter. So you can just push your logs as it is. And yeah, Loki doesn't do any magic during ingestion processing, basically. So yeah, so on the other side, on the coding side, we have a language called LogQL, which is heavily inspired from PromQL. If anyone have used Prometheus, have been familiar. But it's not required to know PromQL to use LogQL. So it is mainly designed for logs from the same philosophy, like where you have Unix style of tools combining with filters and pipes. And it's, yeah, so I just want to point out it's more than just a distributed grep, what you do in local, because the examples I'm going to show you, it will make more clear once you see it. So as long as you process your query with LogQL, then you can do all sort of arithmetic and aggregation joins on your log content itself. If you have any field in your log line, you can do all sort of arithmetic and aggregation on the field itself using LogQL. So yeah, when we talk about on the querying side, there are typically like two types of queries, like log queries and metric queries. So log queries is, yeah, the output is logs. Basically, you do something with LogQL. The output you get is usually your log lines or some part of your log lines. Whereas the metric queries, you generate the metrics on fly, meaning like you can plot it as a table, you can create a graph out of it, kind of thing. So that's the two types of queries you can do with LogQL. So to give you an example, this is what it looks like. It's an example of log query. So if it sounds familiar, that's what I'm talking about, like the pipe style of querying your logs, right? So let's dig deeper, right? What this means. So what it is doing is, let's start from left. So you're asking, give me all the log lines from the app equal to foo, and then filter it, the log line that contains only errors, and then parse it as a JSON. So this is one type of parser. We also have other types of parser, depends on your log line. And the thing to note here is what comes after JSON parser, right? Latency greater than 50 milliseconds. So this latency is actually a field in your log line. So after you parse your log line with a parser, you can treat everything in your log line fields as a key value pairs. So you can do arithmetic on it. For example, it's not like a simple string match, right? Greater than 50 milliseconds. Plus, your latency doesn't have to match exactly with 50 milliseconds, for example, as long as it's some timestamp, and LogQL can parse it fine. So, and the final is a formatter. So sometimes you don't want to put the complete log line. You want to do some kind of additional parsing before rendering it, for example. That's where the formatter comes in. So this is what it looks like. Example. So it's a similar example, like show me all the log lines from job equal to tennis demo app, and filter it for errors, and then parse it as a log format. Probably people from Go world familiar with the log format. And then, yeah, match with some regex matcher, which has a message containing the failed. So, which will give you like your log line plus a timestamp. And this is another query. The only additional thing here is the formatter. So compared to previous one, so here you are just printing only the section of your log line, just the error field, for example. So this template is like a Go template, so it's like a tiny language on its own. You can do all kind of template processing within that line format, just to give you an idea. And yeah, what you saw is a log query, meaning the output will be log lines or some part of log lines, right? So the next type of query is metric queries, which is basically a combination of some log queries, and then you add some kind of function and some aggregation, right? So yeah, the subquery, which is a log queries, which will give you like a list of log lines, whatever that is matched, and then you apply some over time function for a period of like 1 minute past data. That's the idea we're getting it. And once you have that metric, you just aggregate by cluster. Let's say this application is running in multiple cluster. The output will be the metric aggregated by cluster, different cluster. And instead of cluster, you can use any label name, even in your log line, for example. After the parser, like JSON, so everything in your log line will also be treated as labels, key value pairs. So this is one example. So metric query, right? So this is like an instant metric query. What that means is this query is just counting the number of errors occurred in like past 5 minutes of time period, and it's going to aggregate by job and error. So it shows us like, it just only touches the last 5 minutes of data from that instant of time you run the query. So in this example, the error query log timeout has happened in the job TNS demo DB for 138 times in the past 5 minutes. That's what it says. And the same for too many open connections, and same for the other error. So because this is error field, because we aggregate by sum by job comma error. So which will give you like a nice table metric for, this is just based on your log line. Without any instrumentation or anything, you get this metric out of it. And there is another query, which is range query. So the only difference from the previous query is, so since it's a range query, it needs to ask for like, what's the time range. So instead of looking for just 5 minutes, it just, for every 5 minutes, it gives you a data point for the past 3 hours, which means you can plot it as a, rather than the table, now it's a graph. So this is useful, let's say, instead of knowing just only what error occurred or how many times, you can also see how it changed over the period of time, right? So how frequent it is occurring in past 3 hours, 1 day, or 30 days, something like that. And yeah, this, again, everything is just from your log lines. You don't need any instrumentation, for example. So maybe you're thinking right now, like, LogQL is a bit complex, like to learn for the beginners. So there is this thing called like Grafana Query Builder, which is, Loki is like highly integrated with Grafana. So you can build the query step by step with some auto completion. It will display like all the availables, labels you can choose from. And yeah, so the same query you can build by step. First you choose a label filter, then a line filter, then a function and aggregation. So yeah, just by a UI. So that, yeah, this is just like a gist of it, of LogQL. There is much more. So it's like a own language on its own. You can do all kind of things similar to what you do with SQL, for example, but tailored for logs. And yeah, you can go to this doc to know more. There are so many different functions, so many operations you can do. Yeah, we also support a lot of different parsers. The only thing I showed here is JSON and log format. There is also pattern and regex. For example, if you have some unstructured log lines from Nginx or some weird application, you can still use pattern parser to extract the field you want. So that's the idea. So this is from the end user point of view, the taste of Grafana Loki, right? Like as a user, I want to query logs. I want to get something useful out of logs. There is the other side, which is running Loki. The SRE or like DevOps guy who is running a Loki, someone has to run it, right? So we all been in this situation, right? So of course, Loki is a database at the end of the day, so it has its own innovation, like there is a feature coming out, but we also make sure it is backward compatible, right? So let's say in this example, we have something called like schema version, V11 and V12. So let's say whenever we do some optimization on the storage format or index or chunks, we increase this schema version so that you can have multiple schema version for the different period of time. This is one of my favorite part, like what exactly happening here is, so starting from 2022, you can use this new schema version, V12, whereas all the old data, even if you query, it goes to the previous schema, V11. So you don't have to worry about like keeping always the latest version of Loki. And retention, of course. So whenever you deal with the logs, you want to retain the logs for some period of time. For example, one immediate use case is you want to retain dev logs for maybe few days, whereas production logs for months or something. So this gives you a nice, like a fine-grained control over it. So since Loki is also multi-tenant, so the 29 you see here is a tenant ID, the user ID. So you can also have per tenant. So there may be a case where for this user, just store logs for like a month, and for the other user, store it for a day or something, right? And it gets even further. Like you can also even fine-grind to the labels also. So whatever the topological labels you have with your metadata, with your log line. So for example here, keep all the logs coming from namespace equal to prod for maybe 336 hours, which is maybe like a week or so. Whereas for the logs coming from container equal to Loki, keep it for only 3 days, for example. So that's the idea. So yeah, I've been saying Loki scales well, Loki scales well. So to show you some real data, so this is one of the data I pulled out this morning from one of the real cluster we run internally. So we also have like a Loki SaaS. So this is one of the biggest cluster in US Central, so which is serving like around 4,000 active tenants, and it's ingesting around like 60 terabytes a day. And the query path is more interesting. So it's serving around like 12 petabytes per hour, and yeah, 135 petabytes a day. And the interesting thing is the throughput of the fastest query. So it's reached almost like 1 terabytes a second. So yeah, that's because one of the feature we released like last year with the index optimization. So yeah, that's some states if you're curious. And yeah, this should have painted you a picture about what it feels like using a Loki. What I mean by when I say it scales. And now what we're going to do is look at some few core abstractions to get your mental model straight, like why it shouldn't be treated as a full text search engine, and yeah, how do you prepare to use LogQL in that way. So the core thing is data model, right? Loki has simple data model. So at the top, at the right corner, you have your log line, and every log line will have some metadata, we call it labels, attached to it, and we have a timestamp. So the interesting thing to note here, we don't index your log. So we just index only your metadata, right? So if I were you, I'd probably like wondering, what are you talking about, right? So you're saying like it's a log database, but you don't index your log itself, then how can you make it faster? So in our experience running like big database at scale, so probably everyone faces this scenario. Like at one point in time, if you index everything, at one point in time at scale, you're going to reach where your index size is like much more than your actual log itself, like orders of magnitude bigger than your log line itself. Because if you index everything, that's going to happen. So then your problem is different now. So you need to deal with all these hacks to keep this huge index always active. Because then your entire query path is bottlenecked by this index access time, right? So Loki tried to eliminate this problem. I will show you some data in a bit. So in Loki, the index size is very tiny because we index only the metadata. So that's why. So I also wanted to point out the idea of a stream. It's like an abstraction where, yeah, so each logline has some kind of metadata, which meaning like each stream will have, each logline will have to map to some unique set of labels. In other words, every stream will have multiple log lines that you send to Loki. So on the other side, query side, right? So the same question applies. So if you don't index your log line, how do you make it fast? So either you are from industry background, like a practitioner, or from academic background, we have been taught if you want to make anything faster, you index it, right? So yeah, like I said, that's going to come and bite you at scale some point in time. But how do you still make it fast, right? So still you need to query. Like I showed you, like the throughput is almost terabyte a second. So how do we do it still? So this is how. Don't let the image scare you. Let's understand a bit by bit here. So let's imagine you have a query that you see on the top, right? It's give me all the log lines from US Central 1 from this particular job that matches to a particular string, maybe a trace ID or something. So for the sake of conversation, let's say this is like a 1 hour query. It's asking for 1 hour of data, past data. So the first thing, before even processing the query, what Loki does is it splits by time. So it will be split into 15 minutes. Of course, the 15 minutes, it's like tweakable. So it's split into like 4 subqueries. Each is just 15 minutes of length. And it's further sorts the query based on the data. So Loki index is designed in a way so you can look at the query and say how much data it's going to touch, and it can dynamically shard based on number of queries available, right? That's where this horizontal scalability comes in. The key here is to have the control, right? So whenever you need more performance, all you need to do is add more queries. So that's simplify a hell lot of things when you operate systems at scale. So that's a goal of Loki, basically. So yeah, the dynamic sharding with horizontal scaling, so you add more queries, which means like more cores and more parallelization and more faster queries. That's how we optimize the query path. So like I told you, this is like one of the data I also took this morning. So get your mental model straight. For around like 37 terabytes of actual data, the index size is 140 MB, which you can easily load into memory, right? You can load it in Raspberry Pi if you want. So you can always keep this in memory. So your entire query path is no longer bottlenecked by the index lookup anymore, because you can keep this index all the time in the memory. Doesn't matter. So to give you an analogy, right? So if you ask any full text search engine like ELK or anything, so let's say, okay, where is my log? It's going to share you maybe your log in page 15. But Loki is going to tell you your log may be in page 50 to 100 and uses 50 machines to go and process it. That's like a bit of analogy to give you an idea. So yeah, so I hope this should have set some mental model straight, so what it means to use Loki and why some of the design goals and design trade-offs that went into Loki design. So now I'm going to finish off showing some the practices that we learned over a period of time using Loki, operating Loki at scale. So fair warning though, so at the end of the day, Loki is also application which emits logs. So we use Loki to monitor Loki. So this is one of the real log line from Loki. So every query that has been run in Loki, we add this log line. So yeah, I mean, before getting something useful out of your log lines, you need to put something useful, right? So this log line, for example, every query you run, it records user ID, who runs it, and the trace ID if you want to know more, and the exact query that has been run, and then query type, yeah, like a metric query or log query. The length is important here because it also tells you how much it's like a day-long query, week-long query, or month-long query. And the duration is how long the query took to run. And of course, status, throughput is important. Total bytes, like how many bytes it totally touched. Chunk download time is also interesting because, like I said, it has dependency with object storage, right? So sometimes if you see this time is higher, then there may be something wrong with your underlying storage itself. Like maybe that is an instant in GCS or S3, for example. So queue time, high queue time may mean you need more workers to add because some queries are waiting in the queue before picked up by the workers. Source also helpful when you want to know where the query is coming from, maybe from dashboard, from alert, or yeah. So once you have that log line, you can do some cool things, right? One of the often things we want to do is, for every Loki instance, we want to know how much data that it is processing at any point in time, right? So using this query with that log line, what it is basically doing is, it's trying to get all the logs from the query frontend, which is one of the component of Loki. And color equal to metrics.go is the matcher where the log line I showed is present. It's like a unique file which has this log line. And then it's try to match with for all the user, for all the query types. That's what this box does. It's a simple log query. The output of this query is just a bunch of log lines, right? Each log line representing each query that has been run in Loki. So once you have that, you can generate some metrics. So what this does, it just try to take the total bytes field from that log line and try to generate, like, for the past 1 minute, tell me how much data has been processed by this query. And finally, it basically tries to calculate like a per second rate for all the data processed by like 1 minute of period of time. And that's like a one data point. And we do this for maybe like a past 6 hours or past 1 day. You will get a nice graph aggregation like this, for example. So this will tell you this Loki instance, the number of bytes processed is this for the over period of time. This is a real dashboard we use when we run our Loki instance at cloud. Another one final example here is, it's a database, right? So people are going to complain, hey, my query is slow. But how do you know what are the queries that is slow, right? So again, it's almost like a same query. It's a log query. We're not generating any metrics here. The important thing to note here is the last two part, which is duration and throughput. So this is actually a field from your log line, right? So you parse it as a log form, and then so basically what it is saying is, show me all the queries that took more than 10 seconds that has a throughput of less than 4 gigabytes. So something has to be wrong with these queries, why it took more than 10 seconds. So just with this query, you get a nice table like this. So you will know these are the slow queries run by this tenant ID, and the trace ID, if you click the trace ID, it will show you like graph where exactly it spends its time. And then the actual duration. Query hash is important here because sometimes you need to understand, is it the same query that is being repeated, or is it like a different query, which is nice to have. And source, of course. So the cool thing is, at the bottom, these are dynamic, right? Even though it's a field from your log line, now you can put like 20 seconds and see all the queries that took more than 20 seconds, for example. And everything is dynamic. If you want to know for the particular tenant, you can go and choose, hey, for this tenant ID, give me all the slow queries, right? So all this from just a single log line. You don't need to instrument, you don't need to do anything. Just with the log line and the LogQL, you can generate these dashboards kind of thing. So yeah, again, this is just one of the few practices. I haven't covered, like, you can also generate alerts based on LogQL, and you can also like generate, so the metric query that we have seen here is generate the metric query ad hoc, like on demand. You can also generate that metrics and push it to Prometheus, for example. So if the query is expensive, you don't have to run every time. You can just generate the metrics and get the metrics from there. So yeah, those also will be useful. We use it often. And yeah, to summarize, basically, Loki is like a database, like a modern database for logs, which the goal is to have a simplicity, like simple to use, simple to operate, lesser dependency to worry about, like only dependency like GCS store or S3 store. And we saw what it feels like using Loki. Then we look into some of the core abstractions, some of the design trade-offs went into Loki. And yeah, finally, a few practices that we use ourselves. And yeah, that's all I got. Thanks for your time. Happy to take any questions. And yeah, come find me if anything interests you, whatever I spoke here. Happy to talk about. Thank you.